In this video, I'm going to go over kind of a modified version of the homework problem that we did in class yesterday that's due tomorrow. No, due today, I guess. Due like now. Okay. Anyway, so this one asks us to find all of the single parent nodes. Okay, so that's a node with only one child. Okay, so some of you were struggling with this. You were trying to modify an existing one. And again, I think that's just the wrong way to go about it. You have to have a plan first. Okay, so I'm going to kind of go through the plan, then show you the code that I came up with. So I think the problem would ask you to just insert that into the binary search tree file, but I'm going to go ahead and do it as a standalone. Again, just to give us a little more experience or another example of creating a file and pulling in a binary tree to use, which is what typically happens more often. Okay, so here's the tree I've drawn. Okay, binary tree. So I've got 10 up here. It goes to 5, 8, and 9. It also goes to 15 and 20. Okay, and I'll show you in the code. I'm just inserting 10, 5, and once you insert 10, you've set the rest of the tree. So 10 has to go first. Others can go. Well, no, the 5 and the 15 have to go for this. So it has to be by row. So 10 first, and then the 5 before the 8, before the 9, and the 15 before the 20. But if we have this one, okay. So looking at this, we can look at the nodes that are single parents. Would be node number 5, only has one right child. Node number 8 only has one right child. And node number 15 only has one right child. Maybe a better test to have one with a left child, but it shouldn't matter, okay? So the basic way we're going to proceed here, okay, we're going to do the recursive method here. So which means that we're going to start at root and we're going to keep calling it as we go through, okay? So at every node that we hit, okay, there are 4 possibilities for us here, okay? We're going to start with when we're at 10, okay? If the node is empty, what do? We return a 0. There are no single parents, okay? If the node only has a left child, okay, then it is a single parent. So we're going to return a 1 plus however many single parents there are in the right tree, okay? If the node only has a right child, then it's a single parent, and we're going to return 1 plus whatever's the single parents on the right child, okay? And then I may have said the second one wrong. If it only has a left child, we're going to return a 1 plus all the single parents on the left. If it only has a right child, we're going to return 1 plus all the single parents on the right, okay? Or it could be the node has 2 children, in which case we don't return anything new. We're not adding to anything, okay? But we have to figure out the number of single parents of the left and the right child, recursively put those together, okay? So when we start at 10, 10 falls into that last case. It has 2. So how many stepchildren are there here? It's how many there are here plus how many there are here. You call those 2 things, okay? So on the version that called this one, when we're at 5, okay, in this case, it has only 1 right child. So we're going to add a 1 there and move to here. Same thing here, only a right child. 1 more, could be a 2, and move to there, okay? This one here, so the answer now up here is 2. There are 2 on this child. Over here, it's going to go here. This only has a right child. It's going to add 1 more. So there's a 1 on that side. Over to here, it's done. Okay, so you're going to have a 2 here and a 1 here. Add those together, you get a total of 3. Okay, so there are, get this together here. So there are 2. I get that to move. It puts that in a weird place. There we go. So there are 2 coming back from this side. Okay, somewhere it's not going to be in our way. There's only 1 coming from that side, which gives us a final answer of 3. Okay, so that's where we're headed. That's the idea. Okay, in this case, we don't need a trail current. We just need the current. Okay, the current's going to just go through and move, and we should be good. Okay, so over here, I've got the code. I went ahead and coded this up rather than develop it to make a little quicker video. Okay, so I have the single parent. Okay, so again, I'm including the B search tree type CPP using namespace standard. Okay, I've created this function called single parent. returns an integer, that number, and it's going to take a node type int pointer called p. Okay. So we'll start here in main, and in main, I'm just going to create the 10, the 5, the 15, the 8, the 9, 20, which gives a tree on the right. Okay. I'm going to go ahead and print the in order traversal. I do that whenever I'm doing a tree, just to make sure I've got things the way that I expect them to be. Okay. So that should print out 5, 8, 9, 10, 15, 20. Okay. We'll check that. Okay. I then put in a blank line. Now I'm going to figure out the number of single parents. Okay. So when I call the single parent the first time, note if we were doing this inside of the binary search tree class, we would have to have an outer function, so a public function that would just call this on root, okay, automatically. No, it would call the private function, which will take any parameter. So the public function takes no parameters and defaults to sending it to root. The public function takes that. The private function takes a parameter of a node type and then goes from there. Okay, but in this case, I'm not having to deal with all that since I'm just doing it separately. Okay, so I send in a pointer to a node type events. Okay, so when it starts, that's going to be going to the root at 10. Okay. So in this case, I don't need a current at all because I'm not moving through in that way. Okay. I'm just using recursion. I would need current if I were doing a loop, but I'm not. Okay. So at every node that we're at, we have the following cases, just like I said over there. The case that it's null. Okay. If it's null, we return 0. We don't call anything else. Okay. So this is the base case. Okay. Of our recursive algorithm. Okay, so the base case, it doesn't do anything; it returns a 0. Whenever we get to over in the picture, whenever we get to node 9, it's just going to return 0. With node 20, going to return 0. Okay, that's when we're done. Okay, other cases here, okay, that we have. Case 2, there's only a left child. Okay, so the right child is empty. So this is a single parent. Okay, we don't have any of those in our picture, unfortunately. So it's not the greatest test. We can maybe modify that. Okay, but in this case, we're going to return 1 for the node that it is, plus however many single parents there are on the left child. We have only a left child. Okay, case 3, only a right child. Okay, so it's a single parent. Okay, so the left link's equal to null, but the right link is not equal to null. Okay, so we have something only on the right. Okay, so that's going to be 1 because it is a single parent plus however many there are to the right. Okay, and if it's the case that the node has 2 children, like when we start off at root, then we're just going to return a call, again, recursive call, all these except the first one, to the single parent of the left link and a single parent of the right link. Okay, should work, should be fine. Okay, so simple enough. I'm now calling that here and printing it out. So in this case, it should be when I run it. Okay. Single parent.exe, single parent.cpp. Okay. Single parent.exe. When you run it, okay, number of single parents is 3. Okay, which is what we expect. Okay. I want to modify this to make sure that it's working. Let's say instead of 20, I add a 12. Okay, in that case, we're going to have 1 left child. There still should be 3, but it's testing both the right and the left. Okay, I haven't tested this yet, so let's just live dangerously. Still 3. We're good. Okay, and if we just wanted to verify further that things were good, okay, what could I add? I could change that back to a 20. Just so I can add, say, a 30 and a 40. Okay, that makes 20 a single parent now, which would be 4. 30 would also be a single parent, which would be 5. So when I do that, it should give me the answer of 5. Okay. Run this again. Gives me 5. Okay. So I think this is working. I think this is okay. So again, I encourage you when you're getting lost to draw a picture, trace it through, see what's happening, get a game plan, figure out when I'm here, what can happen, turn it into code. Okay. So hopefully this makes some sense. If you have further questions, you can ask about it tomorrow.